Okay, 7th graders, we are wrapping up our data and statistics project, and today we're kind of doing this a little differently than I normally do, because normally I spend a little bit of time on each section teaching you the different types of graphs and ways that we show data. But I'm going to kind of round this all up into one lesson. We're going to let the computer do some of the work for us today. But we need to know why we use certain forms of, charts and graphs to show our data over others. So I'm just going to go over those types of items with you today. So in section 7.3, we have bar graphs, double bar graphs, and histograms. And so bar graphs, we use these when we are comparing things. Okay, so let's write that up here. Used when making comparisons. So lots of you guys asked questions that weren't just number questions. This would be the perfect type of way to organize that data. So for example, if you ask what was your favorite class, you could have English, you could have math, science, social studies, phy-ed, music, and then you could be comparing what your responses were. So the bar graphs are nice because they give a quick visual and show which category, and it can be category or it can be numbers, it doesn't matter, but usually you see them vertically, okay, and then you can easily see which one is greater. This one was showing fresh fruit consumption. Well, which fruit was eaten the most? This is very quick to see that this is bananas. A couple of things that are important to make sure that we pay attention to with bar graphs is that we pay attention to what our axes are labeled, and this is with any graph. This one starts at 0 and goes up by 30. Sometimes they will make misleading graphs, and we don't get a lot of time to talk about that this unit, but they won't start at 0. They'll start with this little zag in there, and it can make bar graphs look more, show that there's bigger differences than there really is. But bar graphs can also be spread horizontally, and I will actually show you guys how to do this on the computer or on your iPad. Okay, so those are pretty easy. I'm not going to take the time to go through all these questions. I think that you guys have been looking at graphs and charts long enough where you know how to do that. The next time thing is that you will see double bar graphs, and I don't know if I saw a lot of you guys asking questions that this would apply to, but maybe. So this is when you would take something, so this is like 3 states. This is the urban and rural speed limits, and so what you would do is you would put those right next to each other. So the states would go along this side, so this would be like Florida. Can't write sideways. And then this would be Texas. And this would be Vermont. And usually you use 2 different colors, or you do different things like this. And so let's do the urban first. This would be kind of city. So Florida would be 65 miles an hour in the urban, and you guys can see that this goes up by 10s. So 65, would be right here. I'm going to do that one in purple. And then we're going to do right next to it, we're going to do the rural, which is 70. So 70. And sometimes if you didn't have colors, you could do them with different lines, so you could see the difference. And then we're going to do Texas, the urban speed limit in Texas and the rural is actually both the same. So we would graph them like this. So part of these lessons are not only deciding which ones to use, wrong color, but also practicing how do we make these graphs. So these ones are a little bit simpler because I've started them for us. I gave you the scale. Otherwise you would have had to make sure that you could go up to these numbers and have plenty of room on your graph. The last one is Vermont. So that one we would go up to 55. So 50 is right here. So 55 is going to be partway between 60 and then 65 would be halfway here. And there's your double bar graph. So, you know, they say choose a scale and interval. The other thing is making sure you label your axes. So here I made sure to put the states down here, and then this is miles, but you're going to want to say, be more clear, state, and then maybe put speed limit. Sometimes we forget that the person that's looking at the chart doesn't know what is graphed. We know it's graphed because we just did it. Okay, so the next thing that we're going to skip to is histograms. Histograms are actually used pretty frequently, especially in stuff that you guys are doing. So histogram shows the frequency of something happening. So I'm going to say up here, shows the frequency. Okay, so we're going to do one here. It says, the table below shows the number of hours students watch TV in 1 week. So I had a question similar to this. Make a histogram of the data. So notice the thing about histograms is that there are no gaps in the data. So 1 to 3, 4 to 6, 7 to 9, and there are no overlaps. Okay, and so if you watch TV 1 to 3 hours, you put this answer. 4 to 6, you put it there. 7 to 9, you put it there. And then this was the frequency. This is the number of students that did this. Okay, so we're going to go to our graph. So a lot of times they've tallied it, and then they have grouped them. So it says choose an appropriate scale and interval. So a lot of times you'll start with this for your information. Okay, so you guys that did your different questions, you could do this with your data. And then they decided, okay, 1 was the least, 9 was the most. Then they made 3 even intervals. Each of these intervals had 3 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the intervals have to be even. So I'm going to put this up here. Intervals need to be equal. That's a big thing. No gaps or overlaps. So for example, I couldn't put 1 to 3 and then 2 to 4. Notice how these overlap. So if you were 3, would you go in this category, you don't know. You can't do that. Okay, so they've already done the information for us, so we're just going to make the histogram. So the histogram down here, you show the categories. So this would be 1 to 3, then 4 to 6, and then 7 to 9. And then this is the number of students, or yeah, number of people, number of students. So what this shows is to 1 to 3 students, how many of those? 15 students watch TV 1 to 3 hours. So I have to go up to 15. So this goes by 4s. So this would be 10. This would be 14. So 15 is going to be right in between there. Okay. And the other thing is that in histograms, the bars touch each other. And the next one is going to be 17. So we know 16. So 17 is going to be right here. I'm just switching colors so you guys can see everything. And then the last one is 17. So it's the same. So we want to make the bars the same size, width-wise, because they're the same categories. And then we can make comparisons. So you can see that there's not huge differences between the number of hours kids watch TV. If you look at the next one, this shows the number of hats a group of students own. So again, they collected the data. So how many hats do you own? Then they would have, 6 students responded that they own 3 hats. Then they decided to split up the data. It was kind of the same as before, and then you would graph it. Okay. So that's a pretty useful way to display data. The next one is circle graphs, and you guys have been using circle graphs for a long time. The big thing when you use a circle graph is when you are comparing parts to a whole. So I'm going to say used when comparing parts to a whole. And great with percentages. So for example, I had a question like, do you own a cell phone? So I was gonna post like yes or no, and I use a circle graph to do so because like this one, it shows the percent of people that own dogs, no pets, cats and dogs. And so they give a quick visual of how the entire population looks. And so this is another useful thing. Your guys' Google form automatically does this for you. Do I think you should use it for every single one of your questions? No, but it's definitely really, really helpful. I'm not going to take the time to answer all these questions. This is just practicing reading circle graphs. I think you guys can probably do a pretty good job at that. And my big thing is understanding that you guys can use these. Again, play with how you label them, how to make them visually appealing to your observer. Okay. The next section here was box and whisker plots. We did that. You guys are required to do one of those on your thing. The last thing that I'm going to, or not the last thing, one of the last things is line graphs. So line graphs shows changes over time. Now whether this is a really useful, and we use this a lot in math, but you're probably not going to use it a lot today because you guys didn't collect your data over time. You just collected data at one time. So line graphs would be used to show data over a period of time. Not used to compare categories. Okay, so for example, this is showing the age and weight of a puppy and how they gain the weight. So just to kind of show you this and to sketch this, this would be the age. The time is usually always on the x-axis, and then this would be the weight. And no matter what type of graph you do, labeling the axes are really important. So you can see that this goes by twos, so I would be 2, 4, oh sorry, this would be 0, 6, 8, 10, 12, something like this. And then what we would do is we'd be plotting our points here. This would be the weight going up. So you'd have to make sure your axes went nicely. It's kind of tricky because these numbers aren't very nice. So it'd be 1, 2, and I'm not going to have room on here to do it, but you guys get the idea. And then what we would do is we would plot our points. And then we would monitor and chart how this puppy was growing. And then your line, you connect them like this. The last one would be up here. So it goes something like this. And then it would continue if I had more room on my piece of paper. So line graph shows the period over time. Again, this is stressing you determine your scales. Okay. This one was months, even though it's January, February, March, April. They're not numbers, but they're still time. And then this one was years. This was decades, it looks like, or actually more than that because it was every 20 years, 1920, 1940, 1960. So line graphs really help you look for trends and to see changes over time. Okay, so that's what they're used for. Like I said, you probably won't use these. Then the last section that we're going to talk about is choosing an appropriate display. And like I said, I've been talking about this the whole time, but this kind of summarizes it. So there are different ways to show data. To choose the data display, think about the information that each kind of data shows. So bar graph compares amounts, okay? A line plot shows the value and how each of the amounts are distributed. You guys need to do a line plot. That's something that's required. This also helps you organize your data, helps you just get a better image of what's happening. A circle graph shows data as parts of a whole. Survey results, yes, no, I don't know. A line graph shows changes over time. You probably won't use this one. Stem and leaf plot shows the value and how the data are distributed. So kind of same in the line plot. I like to use a stem and leaf plot if I have to find the mean, the mode, the median, the measures of central tendency, because it helps me organize my data in order. You also have to include your key when you make a stem and leaf plot. And then a Venn diagram, we aren't really doing this one, okay? You guys have seen this a lot probably in your science classes. I feel like they show the relationships and things that overlap. So that's when you'd use your Venn diagram. I'm going to quickly just go through these with you. It says, circle the type of graph which would best show the data, explain the reason for your choice. So this one says the way a vote is split among 3 candidates in a school election, circle graph or stem and leaf plot. Okay, well, if you are thinking of the 3 candidates, you wouldn't be able to use a stem and leaf plot necessarily, because that would be something like scores or the number of people that own, how many cats someone owns, something like this. So a circle graph, because comparing the whole population's vote. The average income for a family of 4, 1970, 80, 90, 2000. What happens? Line plot. So this is a line plot or line graph. Line graph. Why? Because it shows the changes over time. That's a big one. The points scored by a team during each game in a 16-game season, a stem and leaf plot, or a circle graph. Well, you're looking at points, okay? So it's not like wins or losses. If you were doing wins and losses, that would definitely be a circle graph, but you're comparing the points. So you want to see where they lie. So do they always score, 10 points a game, or do they score 1 point a game, that kind of thing. So this would definitely be a stem and leaf plot, because you're showing how the scores are distributed, and it shows each value. Okay, the calories per ounce in 4 different cuts of meat. So let's say you had chicken, you had beef, you had pork, you had fish. I don't know if they consider fish a meat, but then you're being comparing, okay? And so you would use a bar graph. You're not showing meat over time, you're comparing. So you'd use a bar graph because you are comparing. Those 4 cuts of meat. So it doesn't have to be super complicated, but it is a little bit trickier. I'm not going to attach any homework for you guys to do with this video, but just make sure that you understand which form of which way you should display your data. And then make sure to reach out if you guys have any questions.